Before we can go on to use trigonometry alongside bearings, we need to maybe have a recap of what bearings actually are. So bearings are a way of stating a direction from a certain point, measured from north and in a clockwise direction. So what do we mean by that? So let's take up at the side here, let's draw a dot to represent a point you're potentially standing at, and from there on a map, a direction of north. So imagine looking down on a map and you're standing here, and this is the direction of north. Now say for instance I wanted to find the direction of this point over here and give it as what's called a three-figure bearing. So we'll call this point A here. What I would do is I would draw a line from this point I'm standing at to this point A, and then I would measure clockwise from north. In other words, from this north line I would measure in a clockwise direction until I hit this line. Okay, so roughly I would say that this bearing here is round about 120 degrees. Now, bearings are sometimes called three-figure bearings because we tend to always write them with three figures, which means three digits here. So 1, 2, 3 figures. That means if you get an angle which is less than 100 degrees, for instance, if I was to put a point up, let's see, we'll do this in red, a point up here, and we'll call that point B. What I would do is say if I want to know the direction of point B from this point here, I would join this with a line and I would measure the angle again clockwise from north until I hit this line heading towards B. So this angle here I would say roughly about 45 degrees, but if I want to write it as a three-figure bearing, I would write it as 045 degrees so that I still have three digits. Now we'll get rid of most of that and we'll have a look at what happens if the point I'm trying to find the directions to is a little bit further around. So imagine again, I'm still standing at this point here and I want to find the directions to a point over here somewhere. So let's put again a point, we'll call this point C this time. So I'm standing down here and I'm trying to find how I get to point C, what direction do I need to walk in. Now you might think that it would be easier to measure this angle here, but remember bearings are always measured clockwise. So even though this is the shorter or smaller angle, I need to measure from the north line in a clockwise direction round to here. So the angle I'm interested in for the bearing from the point at the bottom of the north line to C is this angle here. Now, we know that this is 0 degrees, 0, 0, 0, 0, 9, 0, 180 for south, 270 for west, 270 degrees in other words, and this is about an extra 45, so let's say that's round about 315 degrees. So the bearing to C from my point at the bottom of the line there would be 315 degrees. Now what we're going to try and do is use these three-figure bearings to find internal angles within a triangle, and there are some things that will help us do that. Two of the things that will really help us here are understanding this idea of co-interior angles. Because I have two north lines here, north lines must be parallel to each other, and therefore we can use this idea of co-interior angles, which means the angles inside here should always add up to 180 degrees, and that will help us when we come on to triangle problems later on. So for instance, if I was to draw a similar diagram over here, for instance, we have two north lines joining together, and we have 2 points joined together by this line, and say for instance I told you that the bearing from point A to point B was 80 degrees. So let's say the bearing there is 080. Now these are both north lines, which means they're parallel, which means the angle is inside here, the co-interior angles as we call them, these two here should add to 180. That's just a rule you'll need to memorize. So if that's 80, that must be 100 degrees. So I can put that in as an angle here. Now remember, that's not a bearing. That's just an angle in here. But what it does, because I know there's a full turn of 360 degrees here, that if this part is 100, then this part at the other side must be 260 degrees. So the total will come to 360, a full turn, which means I know the bearing from A to B is 80 degrees, but I can also, now using this idea of co-interior angles, I can also calculate the bearing from B back to A. In other words, if I'm standing here and I want to know what direction and to walk to A, then that would be the bearing of 260 degrees measured clockwise from north until I hit that line. And lastly, another piece of information that will be useful, and this is one you should already know, is that angles around a point add to 360 degrees. Now, a lot of the other angle rules you use in first and second year, your complementary angles, supplementary angles, alternate angles, corresponding angles, all of these will come in handy as well, but I would say that these two are the ones I see used most often. So let's have a look at some examples on the next page. Okay, so what I've drawn out here is two triangles. Each of them have points on them for their vertices, so ABC here and ABC here. And some of the points have north lines drawn onto them, so the direction of north. So when you're doing these bearings problem, you've got to almost imagine looking directly down on a map where north is this way, and you're trying to work out the angles here. Now, the idea when we go on to do this with trigonometry is we want to know what the angles inside the triangles are. Because when we do trigonometry, it's the internal angles of a triangle we tend to be interested in. So I've not actually asked you in either of these two examples for any specific angle. What I'm looking for you to do is to take these problems and look at the information you're given and find as many angles as you can inside the triangle. So that's the trick here if we're trying to get angles inside the triangle. Now let's look at the information here. The bearing from A to B is 55 degrees. Now when you're talking about bearings, the word from is probably one of the most important words because it tells you where you're standing effectively when you're taking that bearing. So when you see the bearing from A, it means the measurement has been taken from this point and it's the bearing to B. So what I'm looking to do is from this point measure clockwise from north around until I hit the line that heads to B. So the bearing from A to B is 55 degrees or 055. So that means I can write in this as an angle here of 55 degrees. Now, that's a bearing, so again it's measured clockwise from north around until I hit the line heading towards B. And again here, the bearing from A to C, and again that word from is so important. It means we're standing at A measuring our bearing until we're pointing towards C. So we're standing here and we're measuring clockwise from north until I hit the line that heads towards C, and that's 115 degrees. So we know that's 55, and we're going to mark off this angle here as 115 for blue. So I'm using that kind of colours to kind of distinguish between the two there. Now, what you'll notice here is I still don't have an angle inside this triangle. This triangle has three angles in it, and I still don't know any of the angles. But what I can do is I can use these two pieces of information that I've put on here to help me find out this angle here. So if I look at this, 55 degrees round to this point and 115 degrees round to this point. So I'm looking to try and find out what this angle here is. Now that's just going to be the difference between this and this. So we can do 115, take away 55, which is going to be 60 degrees in there. So 115, take away 55, that's going to be 5 take away 5 is 0, and that's just do 11 take away 5 is 6, so that's 60 degrees. So the idea of this, as I said, with trigonometry problems, we're interested in the angles inside the triangle. So that, or these two bearing sentences have helped us to find an angle inside the triangle. In this particular case, we can't find this angle or this angle. Now, in an actual trigonometry problem, you'd probably be given extra information, for instance, the length of some of these sides, but we're just focusing in on the angles at the moment. So let's look over to this example over here. Again, we're given a triangle, ABC, and north lines at all 3 points A, B and C, and it gives us some information about the bearings of one point to another down below. Now, again, what we're trying to do is we want to do a trigonometry, or use this for trigonometry problems, sine rule and cosine rule. So what we're interested in is how can we find these angles here inside the triangle. So what we need to do is take the information here and just start applying it to the problem and then using some calculations to help us. So the bearing from A to B is 050. So let's mark that off. So again, from A means I'm measuring from here, and I'm measuring clockwise from north until I hit the line leading to B. So that's 050, in other words, 50 degrees. So I'm going to write 50 degrees in that space there. Next, we're going to look at the next sentence here, the bearing from A to C. Now, the bearing from A to C, again, from A means I'm measuring from here, clockwise from north until I hit the line that leads to C, and that's 080 degrees. So, in other words, if I draw a line here, this blue line here is 80 degrees, which helps me then find one of the angles inside my triangle. It means just the same as we did over here. I can find out this angle here by doing 80 take away 50. So that angle in there, which I'm just going to fill in, I'll use a black pen here, is 30 degrees. That's helped me find one of the angles in the triangle. Let's look at the last piece of information it gives us here. It says the bearing from C to B is 290. Now again, the word from here, from C means I'm standing here when I'm taking my bearing and I'm measuring clockwise from north until I hit the line that leads towards B, because it's the bearing from C to B. So I go all the way around until I hit B. And it tells me here that that is 290 degrees. So let's mark that off. We can use a green pen this time. So all the way around there is an angle of 290 degrees. Now again, you maybe think, well, that doesn't help me find this angle in here. So how do I go about doing that? And it goes back to the idea of co-interior angles, angles around a point adding to 360 that we discussed on the previous slide. I know that a full turn is 360 degrees. So if I know it's 290 degrees from here right around till this line, then I should be able to calculate this angle in here without any difficulty, because I know it's a full turn of 360. So 360 take away 290 is a nice easy calculation. That's going to be 70 degrees, which means this angle in here therefore must be 70 degrees. And then that idea of co-interior angles, remember when we're talking about co-interior angles, what I'm meaning is two north lines here, or two parallel lines, and A and B in there. A plus B will always equal 180. Now I have that situation here, so this idea of two north lines with two angles kind of held between them. I have it here and here. That means these two are co-interior. These two should add to 180, and it also means these two should add to 180. So let's start with this. If this is 70, and I subtract that from 180, I get 110, which puts this angle here at 110 degrees. So I'm going to fill that in as well, 110 degrees there. And I'm going to do the same here. Now, from the north line round to this line going to B, we said that was 50 degrees. This angle here and this angle here are co-interior, the same as up here. So these two should add to 180. So we take 50 away from 180, it gives us 130, which we can again write in here. And then we can use the fact that angles around a point should always add to 360. So if we add these two together, we get 240 degrees, and we subtract that 240 from 360, leaving us 120 degrees. So I can now fill in another angle inside the triangle, which is the ones I'm really interested in for doing trigonometry. Now I have two angles inside the triangle, 30 and 120. And remember, we know that angles inside a triangle should add to 180, so let's take the 30 and add it to the 120. That gives us 150 degrees. So subtract that from 180, and that should leave me with another 30 degree angle down here. So 30 degrees there. And you can see there, just from this information about the bearings, it's actually meant I can calculate all of the internal angles of that triangle, which will be a really useful skill in order to go on and do trigonometry problems in the next lesson. So we'll now look at another similar example. So this is again a fairly tricky example. You'll notice the triangle here has none of the internal angles shown, and that's what we're going to try and find out. So it gives us some information around bearings in these two sentences here, and it says using that information calculate the size of the three missing angles inside the triangle. So this angle here, this angle here, and this angle here. You'll also notice that there's already been 30 degrees marked off in this space here. So let's start off with our bearings information. Point B is on a bearing of 320 from C. So again, we're talking about that word from being important. So from C means I'm measuring the bearing from here. I'm measuring clockwise from north until I hit the line that points towards B, which is here. So it's point B is on a bearing of 320 from C. We can draw that in as this angle here being 320 degrees. So a bearing from C going around until I hit the line which leads to B. The next piece of information they give us is A is on a bearing of 290 degrees from C. So again, from C means I'm going to start here and I'm going to measure around until I get to the line which points to A this time. And again, I'll use a different colour so we can see this. And the bearing there was 290. So if I draw around here, that gives us 290 degrees. So therefore, I have enough information now to hopefully work out this angle here. So if I know it's 320 degrees round to here and 290 degrees around to here, then the difference here must be the difference between these two numbers. So how far apart are 290 and 320? So let's subtract 320, take away 290 is an angle of 30 degrees. So we can write that angle in now into this space here. We'll just pop it in there. Okay, and if we've got that angle, that might help us with some of the others later on. Now, The other thing is we talked about this idea of co-interior angles. Remember, that is when I have two north lines or two parallel lines. The angles kind of trapped in the middle, this one and this one, we'll call them A and B. A plus B should always equal 180. That's co-interior angles. These two should add to 180. Now, we'll have that in a few situations here. If we look at this, there's a north line here and a north line here, which means the angle's trapped in between. So where the B is and this 30, these should add to 180, which means if that's 30, take that away from 180, it means this angle here is 150. So we'll just write that in there, 150 degrees. And then over to this side, I'm thinking, well, if I want to find this angle in here, it would be useful to know this one. This one is a co-interior angle. It matches up with this one. These two should add 100 or add to 180 degrees. So I need to find this angle here. Now, we already know the bearing around on this black line here to this is 320 degrees, and we know full turn all the way back around to the north line is 360. So 360 take away the 320 means this extra little part in here, which we can write in again, is going to be 40 degrees in there. Now, because I know this, I can find this because of this idea of co-interior angles. These two trapped inside the north lines here should add to 180. So 40, take that away from 180, should leave me with 140 degrees here. So we can write that in there. And we should also know that angles around a point. So these three angles, 1, 2, 3, these should add to 360 degrees. So let's add these two together, and that gives me 290. And we're going to take that away from 360, and that should leave 70 degrees, which I can write in here. And now what you'll see is I've got two angles inside that triangle. And anytime I've got two angles inside a triangle, I should always be able to work out the third one due to the fact that angles in a triangle add up to 180 degrees. So here I've got 70. Here I've got 30, the two of them add to 100. So if I subtract that 100 from 180, this should leave me with 80 degrees in here. Now that was what the question asked me to do. It said find the size of the three missing angles inside the triangle. So that's 80, 70 and 30. And again, when we go on to do this with trigonometry, that's what we're going to need. We're going to need the internal angles of the triangle.